Welcome back, everybody. We are up to lesson 11 of Unit 7. No new lesson notes in this lesson, so we're going to go ahead and get right into the examples here. Elena and Claire are each working on a project about how high school students are having trouble finding jobs. They each find the proportion of students without jobs from a random sample, then use a computer to do 1,000 simulations using the proportion they found and report the results. Elena says the proportion of high school students without jobs is 0.70 with a margin of error of 0.280. Claire says the proportion of high school students without jobs is about 0.74 with a margin of error of 0.138. Both students reported the margin of error based on two standard deviations from their simulations. What are the mean and standard deviations each student found? For at least one student, show your reasoning. I'm going to show my reasoning for both students just because I'm demonstrating for you all. So for Elena, she says that the proportion of high school students without jobs is 0.70. That's 70%. So that right there is going to be the mean for Elena. And for Claire, the mean is going to be 0.74 or 74%. Okay. Now to find the standard deviation, we're going to use the margin of error. So remember, in a previous lesson, we learned to find the margin of error. We're going to do 2 times the standard deviation. So 2 times the standard deviation. So in this case, the margin of error is 0.280. So that's going to be equal to, for Elena, 2 times whatever the standard deviation is, and I'll just denote it x in this case. Well, this is an easy equation we can solve because I can just divide both sides by 2 and get x equals 0.280 divided by 2. 0.280 divided by 2 is going to be 0.14. So the standard deviation for Elena is going to be 0.14. Okay. Now for Claire, we're going to do the same thing, except we're going to use her standard deviation. So it'll be, or her margin of error, excuse me. So it's going to be 0.138 equals 2x. So now, instead of dividing 0.28 by 2, I'm going to divide 0.138 by 2. So 0.138 divided by 2 is 0.069. So that is going to be the standard deviation for Claire. And that's all we had to do for number 1. So this right here is the answers to number 1. Okay. Number 2. Claire and Elena try to figure out why Claire had such a smaller range of values in her report. First, they consider the proportion they used in simulations. Elena says, my simulation used 0.7 as the proportion since I found that the proportion in my original sample. Claire says, my simulation used 0.75 as the proportion since I found that proportion in my original sample. The students used different proportions in their simulation. Do you think this is why Claire had a smaller margin of error? Explain your reasoning. So what I want to do is I want to call your attention back to lesson 9, I believe. Yep, in lesson 9, we talked about increasing or decreasing margin of error. In this case, margin of error has to do with the sample size, okay? Margin of error has to do with the sample size. So it has nothing to do with the proportion. It has nothing to do with the mean. Remember, 0.7 was the mean for one, and 0.7, this should be 0.74, that's a typo, was the mean for the other. So we don't use the mean when we figure out margin of error. We use the standard deviation, and if we want to increase or decrease the margin of error, we increase or decrease our sample size. So do you think this is why Claire has a smaller margin of error? Okay. The answer in this case would be no, because the mean has nothing to do with the margin of error. As I said, if we need to calculate margin of error, we use standard deviation. And if we want to increase or decrease our margin of error, we use sample size. So that's why that's not the case. Okay. Part B, they look for more differences in their initial sample and discover Elena surveyed 10 people in her initial sample, and Claire surveyed 40 people. Do you think this is why Claire has a smaller margin of error? So Claire had a larger sample size. That's the key to remember. Claire had a larger sample size. And if we look at this, a larger sample size, increasing the sample size, means a decrease in the margin of error. So that is why Claire has a smaller margin of error. So to answer the question, do you think this is why? The answer is yes, because a larger sample size means a smaller margin of error. A larger sample size means a smaller margin of error. And that is it for the examples, and that is it for this lesson.